Okay, hi, this is the African Paleosciences Lab Structured Light Scanner training. To start off, you're going to grab the box. It's a Pelican case that contains the Structured Light Scanner. Usually we put it somewhere like here. Open the box. In the box, you'll find the Structured Light Scanner itself and the tripod. The first step is to open the tripod, and then I will typically connect it while it's still in the box in order to make it safer and easier to carry. You secure the tripod by twisting the knob on the very top side, this knob here. Once you've finished doing that, carefully carry the Structured Light Scanner over to the table where you're going to be working with it. Adjust it so that the scanner is facing somewhat forward on the tripod in a secure position. At this point, it might be worth pulling out the rotary table. Usually the setup's something like this, with the rotary like a foot to sort of 16 inches in front of the scanner. The next step will be to go to the scanner accessories bin. In here, we have all the cords you're going to need labeled clearly. It's important to pay attention to the labels. The first thing we're going to do is set up the rotary. In order to set up the rotary, you're going to get the rotary power box, or transformer, whatever this thing is called, and the rotary cord. Both will be labeled rotary cord. Plug it in like that. Plug it into the surge protected outlet. And then you plug it into the rotary itself. I always like to double check that I am in fact using the rotary cord. We've had some issues in the past with the rotary, so we like to be really careful with that one. The next step for the rotary is to take the cord on the other side of it and plug it into the computer. You can plug it into this sort of adapter if need be, if the other ports are filled. Now we're going to plug in the power for the scanner. Same sort of thing, unwrap the cord, plug it in. Surge protected outlet. You leave this cord unplugged for now. The next step is to grab this cord, which is probably the strangest looking one. It has this big metal thing. Unscrew the further circular dust cap. Take the big metal thing. Inside it, there's a little spot where you can see a spot for a large prong on the sort of furthest edge here. Find where that prong is there, line them up accordingly, and plug it in loosely. Screw in to secure the cord. There's a lot of prongs on this one, so it's good to do carefully. You don't want to risk damaging this cord. The next step, there's like a splitter on the end of this cord. One goes into the Ethernet port on the computer, and the other will plug into the power scanner cord, or the scanner power cord that we already set up. A blue light should turn on the side of the scanner, and that means power is reaching the scanner. Okay, once you have set up the scanning hardware, you're going to log into the computer. You log into the Podrider Lab account, and the password is Lithics. Now you're going to open the FlexScan 3D application. Okay, after the application opens, you'll get a message here that should say System Check OK. There are various errors you might have. A lot of them will just involve restarting the program, and that'll sort of fix the issue. There are other ones, but there's resources on the Google Drive folders that if you need, you can look at, or you can ask one of us who's worked here a little bit longer. The first thing you're going to do once you have the FlexScan program open is click the Projects pane. At this point, you can grab whatever you're going to scan. For our demonstration, we're using just a random piece of Silkrete. Once you have your piece out, of course you want to do quite carefully, You're going to take some of this, which is kneaded eraser, and you're going to use it to secure whatever you're scanning in the center of the rotary table. You don't ever want to push too hard on the rotary table, so it's sometimes best to sort of secure whatever you're scanning in the putty before placing it on the rotary and making sure you have a flat base by pushing it on something like a table. After which you push lightly onto the rotary to secure the object. Do your best to make sure it's not going to fall. Next, you go to New Project, and we're going to title this Training Project. You want to make sure that this is the path to which you're saving all this data. It should be users, project or lab, documents, flex scan, projects. The path will look something like this: documents, flex scan, projects, and in it you'll see all of the previous scans done. So you click OK, and now you can move on to your actual scanning project. On this right-hand side here, we have a pane showing the two different angles that the cameras on the scanner see. You want both of them to be capturing the entirety of the object. You can adjust the scanner by twisting this knob on the front and moving the scanner slightly. You want to be careful to try to have it approximately in the center on both cameras, though it's really hard to get it in the center on both cameras because they're slightly different. So something like this is pretty decent. Next, you're going to select the check mark next to rotary. You want number of scans somewhere between 8 and 12. I typically go with 12. After scan, combine. You click recalibrate, geometry align, continue. At this point, the scanner is going to capture a number of images to calibrate the distance between itself and the object. And the way that the object moves in space. This can take a few seconds. Sometimes this step can be a little finicky, and you might have to mess around with your setup a little bit to make sure everything works. So the error we're getting right now is based on the fact that the scanner is too far away from the object we're scanning. That's why we're getting an empty mesh error. That means the scanner doesn't think it's picking up any data. So you might want to move the object a bit closer, and then we're going to try again. Typically, that empty mesh issue is something you have to worry about most when you're scanning larger objects, because as you try to get the entire object in the frame, you're more likely to move the scanner too far away. To cope with that, you're probably just going to have to take more scans. I don't know if there's any way of moving it further away and still having it work. So after you've done it successfully, you get the message rotary table calibration successful. At this point, you can begin scanning. Before beginning scanning, you want to make sure you've got the exposure levels on the scanner correct. How you do that is you want these images in the pane to show the object with just a little bit of red, not a lot. I'm thinking adjusting to 10 might be a good starting point, but we can always go lower. That seems pretty decent. We're going to give it a scan and see what happens. To do so, you just click the scan button there. And you wait. It's going to take 12 shots of the object.
So the red in the frame indicates that it's overexposed.
Yes.
And the blue indicates that it's underexposed.
Yes. Additionally, though, you can see like darker spots on the object have a lower exposure than the lighter spots. And I usually find slight overexposure turns out better than slight underexposure. These are the types of things you'll probably figure out as you do a number of scans, depending on the object, the material that you're scanning. So after FlexScan has processed those 12 images, it'll start creating a mesh. That's what it's doing right now. It's aligning the scans and giving us a 3D model. Once the process is complete, all of these separate images will appear as one thumbnail. You'll see what I mean momentarily. Okay, there we go. So you have one thumbnail. This little icon here means there's multiple images or scans within that one thumbnail. And as you can see, we have a three-dimensional model of the object. There are a few holes, such as these on the top. One thing that's worth doing if you're seeing holes is reorienting the object so you're seeing the same view as the scanner and seeing if where you're missing is underexposed or overexposed. If you look here, this is a dark spot and this is the missing spot here, which means we're more likely to be underexposing slightly than overexposing. There's a number of different things you can do at this point. You can either hope that you're going to capture that little missing bit with a different angle of the scan, or you can go ahead, I might choose slightly fewer scans and rescan it at a different exposure setting. 15 is probably going to be a bit too high for what we want, so I might go for something like 13. A lot of it's overexposed, but you can see the spot we're trying to capture is still pretty dark, so we're not really sure what's going to happen here. Okay, so now that we have both scans, what you're going to do is you're going to first loosely align them in space. And I think I have that wrong, but because these are so similar, that might be okay. And then you select both scans by shift clicking, where you'll select from the top one to the bottom one, or control clicking, where you can select individual multiples, and selecting mesh geometry in the alignment tab. Doing so should align the scans pretty perfectly. What you're going to want to do next is you're going to want to cut out this bit with the putty that we still have. So, in order to do that, you first have to unlock the scans. It's sometimes best to do this step before you have multiple scans, honestly, and make sure that any scans you want to edit are selected. So I currently have both scans selected, which is what I want. In this sort of viewer window, you're going to press Control on the keyboard while left clicking. It'll make sort of a lasso tool. Select whichever bit of the scan you want to delete. Right click, delete. There we go. So now we have this. Obviously we're missing a large part of the scan we want. If you did have to unlock these, you should go ahead and lock them again. In order to capture the missing part of the scan, we're going to flip the object 180 degrees, so we're getting the exact opposite side. Once again, anchor it on the table. Be careful not to press too hard on the turntable. Set your exposure. As I was saying, I think going slightly overexposed can often be beneficial, so I'm going to see how 11 looks. Yeah, we're getting quite a bit of red. Might be too much, but to me that looks kind of alright. Since it's my first scan, I'm probably going to do 12 again, but that's kind of your own discretion. And then scan. All right. So it's combining the scans for our latest scan. This step, of course, can sometimes take a little bit. All right, so we now have our other view. This is it. I have it selected here. First thing I'm going to do is get rid of that bit of putty. Oh. It's okay if you select onto the scan you're not using as long as it's not selected, but I still get a little bit of anxiety doing so. Delete. There we have our other view. Now what we're going to do is we're going to loosely align it. This can sometimes be a bit of a tricky process. Typically the best way to do so is try to find some feature that's kind of unique. Like I'm looking at this triangle right here and find it on both your scans. It seems like it's right there on this one, so I got quite lucky. Sort of rotate, manipulate it in space until you're sort of roughly in the right position. Then select Mesh Geometry. And as you can see, we have a complete scan now. We're missing some little spots up here. So in order to cope with that, we're going to do what we did last time. Shift click allows you to rotate, by the way, while looking at this pane. So it can be helpful. We're going to look for wherever that missing bit is. Is that the curtain? Let's see. This is always a little bit of a tricky part. So there it is in space. I'm trying to capture the stuff up here, which is what we're missing. As you can see, it's coming through pretty dark. There's spots where the exposure is getting high from the texture, but the majority of the surface is coming through quite dark. So 15 seems like it could be about right to me. And we're gonna just scan again. Ideally, when you're scanning, you'll be getting away with just doing 2 scans. So just one from each view. We're being really thorough here and making sure to try to fill all the holes before we process the final scan. That's kind of the ideal scenario. But sometimes it'll capture all of the data in one scan. It's sort of going to depend on how different the sort of colors of your object are. There's a big contrast between the two. Some bits will need higher exposure and some bits will need lower exposure. All right, sweet. So here's our hopefully final scan. Once again, we're going to cut out the putty right away. Delete. I'm just going to try this. It doesn't always work. Sometimes when you just click Mesh Geometry without even aligning it lightly, it'll be able to figure it out. Sometimes it won't. Typically you need to do a little bit of manual alignment first, but we'll see what happens. Okay, I might at this point go ahead and click abort and manually align it first. There's no point in, waiting if it's going to be a massive processing time for a pretty simple task. Okay, now we're going to try Mesh Geometry. Hopefully it should be a little quicker this time. There we go. So there's a few little spots where we're missing a little bit of mesh. For a scan you're actually using, it's probably best to make sure to get those. Since this is just a training scan, we're just going to show you the next few steps now. This is pretty good. There's nothing too sort of glaring on this. So your next step is you're going to select the first of your locked scans, shift click, and select the lowest one. Now you're going to click Fine Align. This is just going to do another sort of aligning process where it gets a little bit more precision and enables us to do some later steps that we couldn't do if we'd only done mesh geometry. As you can see, the average distance between meshes is 0.015 millimeters, so they're almost perfectly aligned. That's like pretty good. We're very happy with that. Often you'll get closer to sort of 0.3 millimeters, and I think that's usually still pretty usable. So your next step is, with all the meshes selected, you're going to click Combine. What this is going to do is it's going to turn it all into a single model, so you'll just have one thumbnail for all 4 of them. Okay, so as you can see, one thumbnail, one mesh, scan. There's a little bit of weirdness going on here, but it doesn't look too glaring, so we're just going to move on. You're going to click Finalize and make sure you have precise merge selected. If you do smoothed merge, you will not capture the surface texture. It's good to have hole filling pretty high. You don't want to have any texture smooth. And you're going to click OK. There's no reason to delete source scans at this step. Now that we have a nice looking finalized scan without too many holes, a few, you're going to select this button on the top, click hole filling. It'll load the final scan in here. You can't fill holes on unfinalized scans. It's a good thing to know. Not that it should really matter, because it's kind of the last step you want to do. Once the scan is loaded, you'll see over here a little bar which says number of holes. Right now we have 37. First you want to click autofill, and that should get rid of quite a lot of the holes. As you can see, we have 2 remaining. It's going to be this hole here. I believe it didn't get rid of it because this one is a bit too big, and this hole here. We're just going to fill selected. And fill selected. If you're making a scan for study, you definitely don't want to be filling too many big holes like we just did. After doing that, you can click Save All. That's going to save your project. Click on the thumbnail you're using, right click, rename. Name it whatever the object you just scanned is. So we're doing training project. Okay, then you're going to click Save again.
You show the surface texture as well.
Yeah, we're going to do that.
Okay.
Wait, you mean in here?
Yeah. We can't do it in hole filling though. But
Yeah, you just click this, don't you? No? Okay.
Try it. Yeah, it doesn't.
Okay. So just to make sure that you got the surface texture here, you're going to go back to scan. Once it's loaded your scan, you're going to click this button, which shows texture. And you'll see you have the texture of the scan in grayscale. Those places where we have to fill the hole clearly do not maintain the texture. Now we're going to export the scan. To do this, you're going to find whichever folder you're going to and export to it. We're going to export straight to the Silcrete Ply Files Google Drive folder. We're going to delete this scan because it's not an actual useful one. You select OK. It's exporting training project. While it does that, I'm going to find the folder to which we exported it. That should be under Silcrete Ply Files here. Training project. You want to open it in MeshLab just to make sure the texture stayed. This is especially important if you ended up having to do the smooth finalization. If you did the precise finalization, I don't know if there's particularly a need to double check, though it definitely doesn't hurt. So now we've loaded the scan in MeshLab, and as you can see, we have the object all scanned aside from a few little holes and completely three-dimensional, showing the same sort of structure. That's essentially how you take a scan. Afterwards, we're going to put away the scan. The scanner. First step you want to do is obviously put away your item that you were scanning. Be careful to make sure you keep it in the same place as where you got it. Come back here. When you're ready to put away the scanner, you just close the Flex Scan program. You can, put the computer to sleep if that's what you're ready to do. You don't have to. You want to unplug the scanner's power, and then unplug the Ethernet cord. Then you're going to unscrew this, just like you screwed it in. Quickly, doesn't need to be rushed, but put the dust cap back on. Take this cord, put it in the scanner accessories box. Go ahead and unplug the rotary from the computer, unplug the rotary power cord. We typically just sort of move the rotary back sort of somewhere behind the laptop, like that. Take your scanner, carefully supporting both to the tripod and having your hand on the side. Sometimes I'll just put it back in like this and screw the tripod. Put away the Pelican case. We usually leave it sort of here, just to the right of the table. You're going to unplug both your cords. One at a time, take the scanner cord. Here, be careful to just sort of wrap up the cords quite loosely. That's why we're using the big boxes. They can especially get damaged at this sort of contact point. So I just sort of do something like this typically, where I just do like a big loop at the front and then like a loose wrap around the side. Put it in the box. You're going to do the same thing with the rotary cord. One thing to note, when you're unplugging this piece from here on both the rotary and the scanner, try to grab as close to the base as possible. You don't want to be putting undue pressure on that. Same thing where you're just sort of going to loosely wrap it up and put it inside the box. Once you have everything back in, close the box, flip it up, put it on the shelf with the scanner accessories tag facing out. I believe that is sort of the quick rundown of how to use the scanner in the lab. If you guys have any questions, you can contact Saeed or I, or just send in the 3D scanner group chat.